All right, so our topic for today is subroutines. And to be honest with you, this was something that we used to cover in this class. And then 2 or 3 years ago, I pulled it out of our coverage, thinking that it really wasn't a technique that was used that often. And then I had opportunity to talk with some ABAP developers, and they said, no, this is something that they still do. And your book illustrates it in some of its code snippets. So I thought that it would be a good thing for us to put back into the course. I don't think you'll find it to be very, very complicated. Of course, you will not have to write programs using this technique, but you will have to answer questions on it. So we want to make sure that you have a good understanding of it. But I don't think that this is really anything that you will find overly complex here. What's a subroutine? Well, the idea here is that instead of writing a program that is a monolithic program in its logic, we've already talked about one way not to have a monolithic program, which is to use ABAP objects. But this would be another alternative if you are writing a procedural program but want to break it up into different pieces, what you might call different modules. You can do that with subroutines. And so the virtue of a subroutine is it allows us to break up a larger program into different pieces and encapsulate the functionality of different pieces. Now, what that therefore enables you to do is engage in parameter passing. So hypothetically, instead of writing a program that would be represented by this one large rectangle here, we write a program that actually is one fairly large rectangle and a couple of smaller rectangles. And then when it comes to actually data handling, all of our variable data object creation and such might be in this main top block here, and then data is passed to the other modules and perhaps returned from those by way of parameter passing. Now, parameter passing happens a little bit different here than it does when we're talking about parameters being passed to methods, because this is an older technique. So you'll see some things that are a little bit different, but certainly a lot of overlapping concepts. So here's the syntax. To actually create a subroutine, we call it a form. So you have the keyword form, and then you have the name for your subroutine. And then you'll have however many lines of code your subroutine consists of, and then you have the statement end form. And so that creates, if you will, these two boxes that I have drawn here at the bottom of my diagram on the whiteboard. You call the subroutine using the keyword perform, which I think is kind of a interesting little pun. You know, it's called a form, and then you say perform, but that's just me, you know, thinking that's funny. So you see just the keyword perform and then the name of the subroutine. And what I'm illustrating here, no parameter passing, but this would be a perfectly valid way for us to do that. You know, we might, for example, be writing something in ABAP where the user might want some documentation. And so we write a subroutine that is just a bunch of write statements that produce output to the user in the form of documentation. We call that subroutine when it's time to display the documentation. There's no parameter passing, so the subroutine does its thing, displays the information, and then returns control back to the caller, and the line after the perform subroutine code is executed. So it's very typical for the subroutine definitions to be placed at the end of the program source code. So your main block of functionality would be at the top, and then underneath that you might see one or more form blocks. That's just by convention. It doesn't necessarily have to be organized in that fashion. Now, the one thing you do have to be aware of, and this harkens back to, once again, ABAP being a very old programming language that supports backwards compatibility throughout all its many versions, is a subroutine can actually see global data in the program. But we don't want to do that. We don't want a subroutine to violate the principle of encapsulation. So what do I mean by that? Well, let's say that up here in my main program, I create data objects called age and name. And I assign those to values perhaps from the user's input. And down here in this second subroutine, I'm creating some output that involves me including the user's name in that. Well, because name was declared up here in this block and was defined, and because this is all in one source code file, this subroutine can actually see name. But we don't want to do that. What we want to do is we want to follow the principal encapsulation, which says that this block really can only operate on data objects that it creates locally. So it might create its own data object called gender and do something with that, and that would be perfectly fine. But if this block, if this subroutine is going to be using age, we've got to pass it to that by way of parameter passing. Just like you would do with a method in the context of object-oriented ABOP, we do the same thing here with subroutines. So the rule of thumb, really straightforward. If you're looking at a subroutine, the only data that a subroutine can manipulate is data that it defines itself or data that gets passed to it by way of parameter passing. So the only real complex, and it's really not that complex, element of working with subroutines is talking about parameter passing. So let's do that real quick. Of course, when we're talking about parameter passing, we have what's called actual parameters and formal parameters. Mainly the difference here is the actual parameters are what the caller uses, while the formal parameters are what the callee references, or in other words, the actual parameters are on the sending side, the formal parameters are on the receiving side. We've done this with parameter passing related to methods, but I don't know that we really made a big deal about the terminology of actual versus formal. Remember all of the things that we had to worry about with parameter passing for methods. We had importing, we had exporting, we had returning, we had changing, we had pass by value. We don't have that complexity, or we don't have that degree of complexity, but we do have a subset of that here. We have call by value, which we talked about before. Call by value is when the value of a parameter gets copied into the destination variable. So with call by value, in this case, subroutine is operating using a copy of what it is being passed. So if I were to pass the subroutine the name data object, it would not get the original. It would get a copy of the name. It would, it would know that the name is set to Bob or Phil or Phyllis or Janet or whatever have you, but it would get a copy of that as opposed to the original. Call by reference is where it's given the original. And so if it makes a change, that change becomes effective back in the main part of the program. So I might pass it name, where name is set to Janet, and it changes name to Bob, and when it's done, the name is now set to Bob back in the main part of the program. That's the distinction of call by reference. And the idea here is you're not operating on a copy, you're operating on the original. Now, subroutines have a third option that's really interesting, and it's called call by value and result. And I don't know who thought of this, but the idea is it's kind of a blending of those two. The subroutine operates on a copy, but if the subroutine changes the value, when it gets to the end of the subroutine, If there's a different value, it copies it back to the original. So you're not actually operating on the original, you're using a copy, but then if you change your copy, that change is populated back to the original. I've never seen another programming language have this as a mechanism. It's really kind of different. And to be honest, I don't know why. I can't really give you a good case for why you just wouldn't use call by reference in this situation. Because to be clear, there are only two things that could happen here. Number one, you get to the end and it gets copied back to the original. The only case in which it doesn't get copied back to the original is if you end the program. You know, you like terminate the program because of an error. And in that case, it kind of doesn't matter anyhow because you just ended the program. But so I can't really give you a good reason why you would ever use call by value and result and not just use call by value, except to say that it is an option available to you. So you it's kind of the worst case scenario. The reason why you use call by reference is because you want the changes and you don't want the overhead of making a copy. So call by value and result is kind of like, well, you're going to have the overhead of making the copy and you're still going to have the original change. So I don't know who invented that, and I don't really know why, but it exists, and so there it is. So you may someday see this when you're looking at old code, but I'd be hard-pressed to tell you why you would ever actually elect to use that third option. Okay, so one of the things that happens here, as you're going to see, is issues related to parameter passing. And just like we have seen in our calling of methods, in the main part of our program where we create the data objects, we're going to say things like type C length 14 or type P length 3 decimals 1. We're going to see that in the main part of the program. When it comes to the parameters and how they're defined on the accepting end of the subroutine, we can list a type. Now, we don't list type P length 3 decimals 1. We would just list type P or type C. We list them without the length specifiers and without the specificity. But we also pick up a really nice thing here that sounds like it might come in really handy, but in fact, you don't use it as much as you might think. You can create a parameter type any, which means it'll just take any old thing you want to pass it. So I suppose you could create like a write a message subroutine that will let you pass it any old value you want, any old variable, and it'll just write out to the screen the value of your variable is. And you could pass it a string, you could pass it an int, you could pass it a float, you could pass it a date, and it'll just write out to the screen the value of your variable is, and it'll take in anything. Yes, sir?
Is type any dynamic?
Yeah. So, I mean, and so you could call it. You could call a subroutine 3 times in your program. One time you could call it, you could pass it an int, another time a float, another time a string. So this is ABAP's version of generic typing. Now, generic typing can result in a runtime error depending upon your code. Because if you're going to use type any, and you're going to use it later on, let's say with a plus sign, thinking that you're going to be passed a number and you're going to add it to another number, the user could legitimately pass you a string, which is not going to be a syntax error, but when you try and do math on it, you're going to crash your program because the plus sign is not defined in terms of a string operation in ABAP. So you really have to be careful about this use of type any to make sure that if you've written that you make sure you remember what kinds of values are valid. And if you're writing something that will be used by other people, you better make sure in your documentation you describe that although this is type any, you're expecting to be passed numeric values or string values or some other similar specifier. You can do concrete typing, just like we talked about a moment ago. You can do, type C, type P, or whatever have you. And we didn't talk much about this with our call to methods, but you can have legitimately, in this case, automatic type conversion. Now, if you were to write a method that was expecting a floating point number and you pass it an integer, the system would, could say, oh, I can convert an integer to a floating point number, and so it would just do that automatically. Same thing's going to happen here. If you were to employ concrete typing and you were to say that on the receiving end your type was string, and the user called it and passed it an integer, it says, oh, I can put an integer into a string, no problem there at all. And so you can do that as long as you are using types that are compatible to one another. So just to reinforce what I said a moment ago, for data types like P and N and C and X, incomplete data types, we can use those, but on the receiving end, we don't put a length clause. We'll just put type C, type P, or whatever have you. Formal parameters may use user-defined local or global types. So the big thing here is the fact that you can use your own type declarations that you have created as opposed to just using the standard built-in ABAP data types. So let's look at some examples. So here's a subroutine call, and I'm introducing a keyword we have not yet talked about, the keyword using. So in this case, I am calling a subroutine called my subroutine, and I am passing it a data object called main var1. Notice that with subroutines, we don't do what we did with methods. Remember, with methods, we had to say var1 equals this and var2 equals this, and we had to be really explicit. Don't do that with subroutines. Subroutines uses the technique that you are more familiar with from other programming languages, where the order of the variables is key, and it just matches them up in order. Okay? So in this case, I'm just illustrating passing one variable. On the receiving end, this is what it would look like. Form my subroutine, and then I have the word using again, and what I am showing here is pass by value. Okay, so in this case, a copy is going to be made. On the receiving end, I'm calling it subvar1, and I've elected to show concrete typing here. So this is going to be received as an integer. And then I have the code of my subroutine, and then when I'm done, we see the end form statement. The implication of using, no pun intended, the keyword using, is that my subroutine is not going to be changing this value. It's going to be using this value, and that's the extent of it. Note where the word value goes. Pass by value is always denoted on the subroutine definition. So it's in the form statement. On the calling end, you can't really tell whether it's pass by value or pass by reference. You have to look at the receiving end. And it's real simple. If it has the word value and then a variable in parentheses, it's pass by value. If it does not, it's pass by reference. So pass by reference is the default. The call lists the actual parameter. Note that value is not indicated. So I have two choices here, one of which is using. Using indicates that the value of the actual parameter in the caller cannot change based on the subroutine. Now, I may have this as a point on a later slide, but I'll go ahead and mention it here. You would think, given everything we know about ABAP and given the scenario here, that the keyword using surely would be enforced by the syntax checker. And if in my code here I were to use the keyword using, but maybe employ pass by reference, so I'm operating on the original, and then I tried to put it on the left side of an equal sign, you would expect the system to complain and say, no, 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 you're changing the value of something you said was using. System doesn't enforce it. It's basically just there for documentation purposes. And so you as a programmer should make sure you are using the correct word. But as a point of fact, using is not enforced by the system. You could change it if you were so inclined. Now, you shouldn't do it. I'm just saying it won't be flagged as an error. And in this case, even if you do change it, it's passed by value, so it's no big deal, okay? Which sounds like I'm condoning it when I'm really, really not, okay? So you have another option, which is instead of using the keyword using, you can use the keyword changing. Those are your only two types of parameter passing. So you don't have any of that import, exporting, receiving, or whatever. We have using and we have changing, which basically just signals the fact that, yeah, I'm going to use the data you pass me, but nothing else. Or, hey, I'm going to change this data that you are passing me. So, on the receiving end, you'll see the parallel of that, okay? So, once again, let's assume that that was either using or changing. You'll notice the big difference here is I don't have the value. I don't have value subvar1 in parentheses. When that is not there, I'm using call by reference. Okay, so this slide right here is showing call by reference. Note value is not used. That means that I'm operating on a copy, or in this case, I'm not operating on a copy. The subroutine is operating on the original data object. Since the subroutine is operating on the original actual parameters, changes it makes are effective on the original. If the module will be making changes, use the keyword changing. If it will not be making changes, use the keyword using. But, as I just mentioned, the difference between using and changing in this context is strictly for clarity of design. It is not in any way enforced by the system, which once again points to why I think that this is just a really poorly implemented portion of the ABAP language. But it does still get used. Any questions about this? So we've now talked about pass by value and pass by reference. What we haven't talked about is the pass by value and return. Here's that. How does call by value and result work? And remember, call by value and result is you operate on a copy, but when you're done, the copy gets copied back and overwrites the original. That is done when I use the keyword changing with the keyword value. Okay, so notice what's going on here, and you see this most importantly in the subroutine definition. I have value there around subvar1. So we know I'm operating on a copy, but I have put that in a changing block. And so the system will see that, and it will say, oh, hold on, this is passed by value, but it's also changing. So it knows when it gets to the end of the subroutine, it's going to take the value and overwrite. In this case, if subvar1 gets changed in the subroutine, when it's done, that's going to be copied back to main var1. Okay? So the use of changing indicates that at the successful end of the subroutine, the final value of the formal parameter will be copied back to the actual parameter. Okay? So the value of subvar1 is going to get copied back to main var1 in this situation. So I know I'm doing normal pass by reference when I just don't see the word value show up anywhere at all. I know I'm doing pass by value when I see the word value and I'm using the using statement. I know I'm doing pass by value and result when I see the keyword value along with changing. And that's kind of it, okay? Let's look at some code here. I gave you this table right here, which pretty much just summarizes the scenario that I walked you through a moment ago and what I said the different options were. Anytime a copy operation is part of parameter passing, you're going to see the word value show up. So anytime you see the word value, you know you're going to be talking about working on a copy. The only difference here is whether the copy is going to be copied back to the original, and that happens if the keyword changing. Anytime the subroutine will change the value of the formal parameter, changing is used as on both sides of this. Call by reference use of using is a design contract to not change the value, but as we've observed now a few times, this is not enforced by the ABAP language. Yes, sir.
So on the final, can we go back to just the code, the syntax for, if you were to say, just interchange changing with modify, true, false, subvar will be copied back to main bar. Technically, that would be true.
All right, give me the whole thing again.
Instead of changing, because ABAP doesn't enforce using and changing, if you were to put that code up there and say using where changing is, would that not technically be true? Subvar 1 would be copied back.
No, it does not get copied back in that situation. The only time you get the copy back is with the keyword changing there. Yeah, so that is a good point. And that's the reason why it only comes into play relates to the last one. With call by reference, you're passing it the original. And if you're telling it using, you're assuming it's going to take the original, but it's not going to mess with it. And if it messes with it, though, it'll be allowed to do so, is the idea. So what I've shown you so far was just an example that only showed one parameter. So let me show you a more complete example here. If you have both using and changing, you list them in that order. Notice there's no commas or anything like that. You're just listing all the different parameters here. So in fact, my subroutine, you'll notice, is assigned to take in 4 different values here. And so, by the way, in this particular example, what's missing? When I was creating this slide, my focus was on showing you using and changing and everything else. I'm missing the type statements. So this should say using subvar 1 type C or value subvar 2 type any. Okay, so that is not shown here. Okay, because I just wanted to get used to this. Is what I said before. It's just going to match these up in order. So in fact, as terms of identifying the parameter passing here, main var 1 matches up with sub var 1. It's using, and the value word, the word value is nowhere to be found, so I know that that's just normal pass by reference. With main var 2, you'll notice it matches up with sub var 2, which uses the keyword value, so I know that's pass by value, and it's the using statement, so it's just straight up pass by value. If I go down to changing, main var 3 matches up with sub var 3, but I'm using the word value. So the implication is main var 3 is going to get copied into sub var 3, but when the subroutine is done, whatever the value of sub var 3 is, it's going to be copied back into main var 3. And I want to emphasize, there's no way to say, no, don't copy it. It's not like you have any control over it. That is going to happen 100% of the time, which, once again, to me, kind of makes me wonder why you're doing call by value and result instead of just straight call by reference, because I can't figure out why you would want the overhead of making a copy without the security that using a copy affords you. That's the only reason why you ever use a copy in the first place. So, in summary, although a subroutine can operate on global data, don't do that. Your subroutine should be defined such that they only operate on data that they define locally or things that are passed to it by way of parameter passing. Pick the most conservative method of parameter passing based on your design goals. Call by value has the benefit of providing data object security. The subroutine's working on a copy, so it can't mess up the data. So that's a good thing to do. Call by value and call by value result have the disadvantage of overhead with making data object copies, and so you want to avoid those, particularly for large data objects, because the last thing you want is a subroutine making a copy of an internal table or something else of that sort that will result in the program being slowed down. What happens, how do you end a subroutine? Well, I kind of already showed you this before, but there are some options here. The end form statement goes at the end of the block. So you had the form and then the name of the subroutine and then a block of code, and then you have end form. But suppose you want to send the control flow back to the caller before then, you can also use a return statement. So you can only have one end form statement, but you could have multiple return statements that you might put in the context of conditional logic. If this particular scenario occurs, return. But otherwise, keep going. So you're not at the end of the subroutine, so you use return here. And realize if you're doing call by value and return as your method of parameter passing, whether you use a return or an end form statement, the parameter values are getting written back, okay? If you wanted to end your program, you actually have two options. We've already talked about how to use messages to abort a program or exit a program. You can do it that way. You can also use, I don't know that we've covered this, you can use a stop statement. If you just put that keyword in, presumably inside of conditional logic, that's going to end the program too. Just the keyword stop. Once again, probably message is your better alternative because then you can at least tell the user why their program just ended. But if you just want to like say, hey, I'm done, stop. And the program will just stop at that point, and the user will be sitting there wondering what happened to their program. So once again, you can use the stop statement, but using a message is a more preferred value. And this is kind of obvious, but when you do this, the parameters are not written back to the callers, okay? Because the program just ended, okay? So, you know, at that point, the variables are just left hanging, okay, along with all the other stuff there. All right. Questions about subroutines?
A couple.
Mm-hmm.
I noticed that in the slides, and even as we were talking about the return, previously we would define a definition and then have an implementation. So subroutines is kind of inverse then with the caller and then the definition. And then where does that go? Does that go in the start of selection?
Start of selection.
Put this into a program that we've already written?
If you like, typically you would have your main program at the top, and then maybe at the underneath that you would have you would have your let's go back here. You would have your form block. Okay, so a form block basically exists outside of control flow until it gets called. So you could have multiple form blocks at the top that the system would just look at and say, oh, there's a subroutine. Oh, there's a subroutine, and would just skip over them until it hits either a start of selection statement or the first line of code that's not in a form block.
So would you put your form blocks in the definition of your class?
Well, this is procedural.
Okay.
So I'm going to bet, although to be honest, I haven't tested this. Remember when we said there are certain things that you can't do when you're writing an ABAP objects program. I'm going to bet if you wrote an ABAP objects program and tried to put in your own forms, it's probably not going to, well, it might let you do that inside of a method. It might let you in a method call a subroutine. But I'm going to think that that's going to be pretty rare, particularly for a user-defined subroutine. Okay. Other questions? And by the way, I'll just say this as an aside. Remember last time we talked about ALV grids? Okay, there are ways of calling ALV grids that match up with subroutines, where you use the perform statement and pass parameters to procedural code to paint the ALV grids and such on the screen. Okay. Other questions? All right, so Thursday, if you want to stay home and, of course, use that time to study ABAP, I encourage you to do that. If you want to come to class that day, the only thing I ask is come with questions. Otherwise, we'll just sit here and stare at each other. But I'm absolutely happy to come in on Thursday. And questions other than, can you tell us what's on the final? Because that's one I won't answer. But we'll get together on Thursday. If anyone's here today and didn't sign in, please come and do that. If you wind up with any questions about anything between now and Thursday, of course, you're welcome to come by my office or send me an email. However I can be of help, I am happy to do so.